Hello, little ones. Welcome back to the Duckyard, and today we're continuing on with the series of the RC Power Jet Car. So far I can see this is the last one, but I do see part on the title itself. It says, give me a sec, World's Fastest RC Jet Car 3.0 Part 1. So if this is Part 1, then there might be more coming in the future. Who knows? Anyway, crappy snacks, crappy babbies. Let me know what your comments eating in the comment section down below. Ooh, I just messed that up. And let us get right into the video. Anyway, we're back. Let me just set up my model. Yeah, this looks way much better, and it looks like it's carbon fiber. And this is 18 minutes long. Ooh. Let's watch.
In this video, you'll see how I built an RC jet-powered car, one of the most powerful RC cars in the world, with a fully carbon fiber monocoque chassis and a powerful jet engine taken from an RC plane. And started on a journey towards my next RC car land speed record, where we would see just how fast this thing can go on a runway, completely unrestricted. I wanted to build a new, highly advanced RC jet car to see if I could achieve a much higher top speed than my previous jet car that in 2023 set an official Guinness World Record for the highest speed achieved by a jet-powered RC car at 94.
I heard that you have to pay them to put it into the Guinness. Like, you first have to pay them to say, hey, put me in the Guinness, and then they give you your reward. Yeah, that's what I've learned. Like, I've actually went to test, did a little research. You actually, they don't actually give it out for anybody, you know? You have to pay them. Give you the Guinness World Record.
0.76 miles an hour. The plan was to build a new car in time for the summer speed events put on by ROSA, the radio-operated Scale Speed Association. These events are some of the only places in the world where RC car drivers can push their cars to the absolute limit, to see just how fast their cars can go on an effectively unlimited stretch of flat, smooth runway with proper timing gates and official timekeepers. Some of the electric cars at these events regularly hit speeds of over 200 miles an hour, so it's a pretty serious business. So, my goals for this project were simple. Could I 1. Build a new jet car in time for ROSA, 2. Smash my own land speed record, and 3. Importantly, bring the car back in one piece. But none of this would be easy, and to be successful, I'd have to make some better engineering decisions than on my previous jet cars. Because after what happened on the last one, I was pretty sure I would never try this again. Way back 3 years ago, I had the bright idea to combine an RC jet engine with this RC car chassis. The first car that came out of this actually turned out to be extremely fast, unofficially getting up to 118 miles an hour on a local racetrack. I knew I was onto something. The next car I built was far more advanced, with a fully metal CNC cut chassis, and this was designed to use the front and rear subframes from the Armour Limitless. This car was designed completely differently to the first car, mirroring the design philosophy of the real land speed record car Thrust 2, which in 1983 set a land speed record of 633 miles an hour, with record-breaking legend Richard Noble at the wheel. During initial testing, this car proved it worked really well, doing 70 miles an hour on its first time out. Next, it was taken to the closed runway of Llanbedr Airport. On the very first run, it blasted through the timing gates to set an official land speed record of 94.76 miles an hour for the fastest speed achieved by a jet engine RC car, which was my first Guinness World Record.
Well done! Hey, well done!
On the next run, I achieved a big step up to 137 miles an hour, but this run unfortunately didn't count as an official record, as the nose of the car detached at high speed. Due to me forgetting to reinstall some crucial retaining bolts. The next day I would make another mistake, but this time with much more serious consequences. There was a big crosswind over the runway, but I decided to run the car anyway. This would turn out to be a very unwise decision. Unfortunately, it all went wrong. The car was blown off course by the crosswind and crashed spectacularly. There was nothing left. Just like that, my 2023 jet car campaign came to an abrupt end. The car had been doing so well, and we put a heck of a lot of effort into this project, only for everything to end up being destroyed. On my return home, I was almost entirely convinced I would never build another RC jet car. But then, something rather unexpected happened. I received an email from Richard Noble, the original record breaker who built Thrust 2, which had really inspired me to do that project. Very kindly, Richard sent me a book written by Thrust 2's chief designer, John Ackroyd, and inside he'd written, "Now you can go much faster." So that was the decision made. I'd go again and build on what I'd learned. So all the way back in January of 2025, I got started on the new design. It was time to build a next generation RC jet car.
That's not bad. It looks a little weird though. Do you have the budget for that engine?
Just like the last car, this car would be designed around the engine. The engine would be the same size as before, a 220 size engine, providing 22 to 23 kilograms of thrust at sea level. The car would also use the same wheels and suspension as before, taken from a brand new Armour Limitless chassis. Armour actually sent over for this project, so thanks to them for sponsoring the car. Now I could start to come up with a new monocoque design for the car that would be more streamlined. The new aerodynamic concept I came up with was to actually go with a sleeker and more narrow design with less frontal area than the previous car. This would hopefully be faster, even with the extra drag of the F1 style open wheels. Open wheels would be more practical for being able to drive this car like a normal RC car up and down the runway without having to manually place the car on the start line. The drag offset from the open wheels though would be significant, so would it actually be any more efficient than the previous car, even with its smaller frontal area? Well, these days you can get your hands on some pretty impressive tools for running virtual wind tunnel tests, and helpfully Airshaper were excited to lend a hand with this project, giving me full use of their software. I first used the program to develop my initial model, looking at where the drag was coming from and where areas could be improved. Over time, the car evolved to be more streamlined as I tried new versions, changing the shape of the body between iterations. Next, I could compare the new design to the old 2023 car to see if I'd made any improvements. Looking at the data that came back from the simulations, it was clear to see that the new car was just about better than the old car, and this would mean it would theoretically be faster with the same engine. So I had a design, but how was I going to manufacture this complicated streamlined shell? Well, advanced engineering projects are all about collaboration, and I knew exactly the right people to ask for help. Easy Composites. For those not aware, Easy Composites is a manufacturer and supplier of materials and equipment for advanced composites. But really impressively, they have an incredible YouTube channel where they show how to make things from carbon fibre. After a few emails, I went to meet Paul at their headquarters, where we could go over the design in depth.
All right, okay. Very well, very well. That's what we're going to do that, butchering? Yep.
The main problem we had was how to turn my fairly rough CAD model into a mould for making the finished parts.
So we're only using the, take this off, the front and rear sort of subframes.
Yeah, so and they just detach straight off from that.
Yeah.
We needed to make sure that the engine would be nicely packaged within the shell and that crucial aspects of the design, such as the intake geometry, would be practical for making in simple CNC cut molds. An RC land speed record car monocoque wasn't going to be the easiest of things to make, but if anyone could pull it off, it was Easy Composites.
There's so many different
How long have we got?
configurations. About 3 months. Or
3
something.
months. No, how long have we got though? You got 3 months.
If we could have about a couple of weeks, then that'd be great.
If Paul could get this done in 2.5 months, I would have about 14 days to finish it off before Rossa. A bit tight, but I could probably just about manage it. Hopefully we wouldn't have any delays.
All good.
All right, well, carry on, and I'll see you in a few months.
Yeah. Brilliant. Thanks, mate.
My original CAD model wasn't quite ready for use in making the molds. Edwin, their resident aerospace engineer, spent weeks refining the design, and in the end came up with a perfect CAD model to work from. We had to make sure that the model would be practical for making molds from, and that the parts would come out of the molds when it came to the all-important release stage. As you can imagine, this carbon fibre layup process all took a lot of skill and patience, and of course took a long time to get absolutely right, especially when it came to the resin infusion. The parts needed to be made with a higher temperature resin system to deal with the heat of the jet engine.
Oh.
Thankfully, it all came together, and this was thanks to the massive experience of Paul and his team. I definitely couldn't have managed anything like this level. A massive thank you to Easy Composites for their huge contribution to this collaboration. Easy Composites have made a 30-minute video on their part of the project, so subscribe to their channel for more stuff like this. Finally, after months of anticipation, the rolling chassis was finished, and the day had arrived where Paul and his team could drop it off at Project Air HQ for the final build. I was extremely excited to see the result.
Are you ready?
Whoa! Oh my god, the finish. Already, I've not seen anything RC related that looks this nice before. That looks incredible. That is, oh my god, it's like way better than I thought it was going to be. That looks like the most insane RC car ever. Thank you very much.
This will be expensive as well.
Safe to say, I was quite astounded at how good the car looked, but
Now this time, don't wreck it.
also a little daunted. The car was now probably worth more than my full-size car in all of the material, labour and design work that had gone into it. I better not mess this one up.
Oh, it looks so good with the wheels as well. It's like a Formula 1 car mixed with a missile. So the question now is, how fast can you make me another one when it's crashed? I'm joking. This one is not going to crash.
No. Put some active downforce on it, keep it on the deck.
There is a heck of a lot of stuff to do before the Rossa event at the weekend. We've got a few days to build this car up into the finished running thing, and then we'll be shipping it all out to the event.
With a project like this, there's always a whole load of unknowns when it comes to the build, and the first thing I had to figure out was if the engine would actually fit. For my initial attempt at breaking my own 94-mile-an-hour record, I decided we would use a smaller engine than the 220 size that the car was originally designed for. Although this would only be about a third of the size of the previous engine, I calculated it would still be more than sufficient for initial running. This would keep the car much more manageable to start testing with, and very much lowering the odds of immediately smashing up this beautiful carbon shell. From my previous experience of RC land speed record breaking, I'd learnt that good decision making is essential at every stage of the project, not just before a run. Hopefully this would be one of those good decisions. Before fitting the engine, I still needed to finish the front and rear brakes. These would be exactly the same as the ones on the previous car, with front and rear independent disc brakes fitted to the original Armour Limitless differentials. This would provide a really bulletproof, strong mechanical braking force, and mean I could even adjust the brake bias towards the front or rear, just like a real race car.
This is just a quick test of the brakes. It stopped.
Now to mount everything properly. The engine and electronics were mounted on a lot of 3D printed parts, something that doesn't immediately sound like a great idea, but I'd previously found out on other jet-powered projects that areas around the engine stay quite cool. A huge shout out to Accu for hooking me up with all of the M3 and M4 stainless steel hardware used to fasten everything together on the jet car. If you're interested, I used their new quick order feature to save a list of all of the components I used. If you want to try building an RC car like this, you can easily get the exact same parts using the quick order link in the description. I ended up upgrading a lot of the 3D printed parts I made for this project myself to CNC cut aluminium, and this was made possible by PCBWay, who are sponsoring this video with a quick ad. PCBWay is great as they allow you to simply upload parts to their easy to use website to have them machined and sent to you in just a few days, opening up a whole world of possibilities. And it's not just metal parts either, there's all sorts of types of small scale manufacturing that they provide for makers and hobbyists, such as PCB prototyping, 3D printing and CNC machining. They also do sheet metal fabrication, injection molding and OEM. There are so many different processes you can use to make
Hang on
parts from
there.
different materials. For example, in their CNC machining services, they support a variety of materials, including but not limited to aluminium, stainless steel, brass, copper, titanium, and even carbon fiber. Also, the PCBWay figurine design competition to design a 3D model based on PCBWay's official mascot is currently running, where you can get cash and coupon prizes to put towards your next project. You'll also even get a free mask on your next order. So head over to PCBWay with the link in the description to get started making parts for your own projects. We were running out of time to get the car finished. I still had to find time to test the car before the event. Months of planning, and it still sometimes comes down to the wire. Still, we were very nearly there. It's just gone 9 o'clock. Got the fuel systems, they're all in now. I just need to drill some holes in this beautiful carbon fibre in the side here for the fuel vents and the fuel filling port. It's going well though. I think we're going to make it for the speed
He
event.
looks tired. That breaks my
Radio gear is
spirit.
mounted as high as possible off the road so it wouldn't have interference from the runway or carbon fibre shell. Another important addition to the car was a skid, just like an F1 car uses to protect the carbon floor. Just in the nick of time, the final component has arrived. It is a big round tube. I'd found sourcing a suitable jet pipe super difficult, so I was relieved that this aluminium pipe seemed to be perfect.
It's perfect.
However, at this time, I didn't know about the rapid heat transfer properties of aluminium compared to steel. Would this be a bad idea? I would soon find out.
Yeah.
After about 5 months of work, it was finally time to hear the car come to life for the first time. I made sure to anchor the car to something that was definitely not going to move, if I remembered to put on the handbrake at least, and powered on the electronics. The fuel was a mixture of paraffin and jet oil, and this was carefully pumped into the onboard fuel tank. Fully fueled, the car would have just 3 minutes of running time. So, would the car work? Or would it simply burst into flames? Okay, going up to state, ready. Okay, ignition. The car was running. Success. A very big milestone for the project complete. Okay. The aluminium tube had got extremely hot during that run, but thankfully it wasn't melted and the high temperature resin system of the car's shell was holding up. I spent the next couple of days testing in the car park, running up and down, adjusting the brakes and getting used to the controls. The car sounded incredible.
Very good.
Yeah, it's testing.
With the car
That
fully
is death by
assembled
now.
and with onboard cameras installed, I could do one final check. Hopefully nothing would go wrong at this late stage.
Sounds aggressive.
That sound never gets old.
Okay, it's gone into cooling mode, that's brilliant. And everything looks nominal. Hey!
Finally, after months of work, my new RC Land Speed record car was finished and ready for action. We had multiple sponsors, one heck of an RC car, and all of the familiar pressure to make this thing a success. It was time for my next crack at a world speed record, 2 years in the making. But would I have learnt from my previous mistakes? We would only find out at the runway. The next part of this project is coming out in just 2 weeks' time, so make sure to subscribe to Project Hair.
No, really? We're not gonna figure it out? You gotta be killing me. 2 weeks. When was this made? Come on, give me the information. Give me the information. It's not telling me when it was made. Hold on. About 2 weeks. 31st. Okay. Oh well. March. This was back in 2025. What? I guess we'll just have to see it next time. I'm sorry, guys, but yeah. I thought that would have been all of them, but apparently it's not. Anyway, I hope you all enjoyed that video. Yeah, I know I did, but I was left in a cliffhanger, but good news is it was, back at, on 31st August 2025, so we should have enough time. We'll see that later. Don't forget to check out the other videos I've made, and as well, I'll see you later. Thank you for watching, and as well, bye-bye little ones.